Welcome to Unit 7, Lesson 13, Definition of Scientific Notation. Today we're actually going to use scientific notation to describe large and small numbers. I'm really excited about this lesson because I really enjoy scientific notation. I think it's kind of fun. When we talk about this first thing in this number talk section, multiplying by powers of 10, we use scientific notation to actually help us multiply very large and very small numbers and write them in efficient forms. And one way we can do that is to be thinking about how many times larger a number is. We've talked a lot about powers of 10, and powers of 10 meaning like specifically the 10,000. What we know about the 10,000 is that is going to be 10,000 equals 10 to the fourth power. I know that it's 10 to the fourth power because if you take 1 and multiply it by 10, you get 10 times 10 again is 100 times 10 again is 1,000 and 10,000 for the fourth time. A simple way to think about powers of 10 is you can count the place values that come after the 1, and this will indicate how many powers of 10 there are. So when we think about 123 times 10,000, we can think of 123 groups of 10,000, or 123 times 10 4 times. In this case, we can simply add 4 zeros onto the end, but I do not want you to start thinking that this is how scientific notation works. It does help us to mentally calculate these values pretty quickly and pretty easily. 3 and 4 tenths means that we're going to multiply by 1, or times 1,000 means we are going to multiply by 10 to the third power. So 10 to the third power, when we start with 3 and 4 tenths, we can think about moving that decimal to the right, increasing to the right 3 powers, or 3 place values. There's 1, 2, 3. These empty place values, we can put in zeros, and they will represent those powers of 10. You can see that 10 to the third power is represented by these 3 place values that are given. So 3 and 4 tenths times 1,000 is 3,400. 6 tenths times 100, we can think the same thing. At 6 tenths, we multiply by 10 to the second power, as that's 100, times 10 is 1 place value to the right, times 10 again is another place value to the right, making 6 tenths times 100 equal to 60. Now, when we get to a smaller number like this, a number that's less than 1, we have a power of 10 that's actually into the negatives. When we look at this power right here, we see that we are 2 powers of 10 less than the ones place. So we know that 7 and 3 tenths is going to be multiplied by 10 to the negative second power. When we set this one up, we actually go in the opposite direction. When we're talking about negative powers of 10, we have to continue to get smaller. So 2 negative power, 10 to the negative second power means that we're looking at 2 place values to the left, or 100 times smaller than what we were at with the original value. And so 7 and 3 tenths times 100th would be 73 thousandths. And there you go. All right, today we're going to get the formal definition of scientific notation. I have talked about this in previous lessons, but I would like to review it again. The formal definition of scientific notation tells us that we have any value, d, we call that the finite decimal. The finite decimal has rules that are associated with it. That value of d, or the finite decimal, in order to be scientific notation, is that first number that we see, as this example right here. It's that number that we see that will be multiplied by the power of 10. D has specific rules where it has to be greater than or equal to 1, and d has to be less than 10, meaning that the finite decimal has to be a single non-zero digit. This digit right here at the very beginning, we call that digit the leading digit. And as we look at that leading digit, we have to recognize that it follows this rule. If it does not follow this rule, it is not scientific notation. The final part of this is we're working with a power of 10, and we have to multiply by a power of 10. No matter what the value is, that's the only way we can do this, is it has to be a multiple of power of 10, or else it's not scientific notation. If you see adding a power of 10 or subtracting or dividing a power of 10, it's not scientific notation. That power of 10 is going to be represented as 10 to the nth power, where n is not equal to 0. All right, knowing that, we can go ahead and look at these values and we can recognize how to write these values in scientific notation. So we see some of them, they may or may not be. Circle the speeds that are written in scientific notation, write the others that are not. Obviously, this first one, 300 million, is not scientific notation. We look for the first digit that is a non-zero, which is 3. That will be our leading digit. And in this case, we could have 3.0 if you wanted to, or you can just leave it simply as 3. Typically in scientific notation, you'll notice that we write it with an X. I have written it in different ways. If you're not using an X, you need to put decimal values inside of parentheses. So this one, we typically use an X for the times symbol, times 10. And now it's important to count all the other place values back to where the decimal is. So in this case, don't be misled. We're not counting zeros. We're counting place values. So in here, I see 3, 6, 7, 8 place values. So this would be 3 times 10 to the 8th power. When we look at water, we go ahead and look at the value that's given and we compare it to the rules that are given. This is my finite decimal. And I know that that finite decimal, 2 and 25 hundredths, is definitely at least 1 and less than 10. I see multiplication and I see a power of 10. That is scientific notation. Copper is not written in scientific notation. This is what we call standard notation. Find the finite decimal by placing the decimal point after the first non-zero number. And then these values that come after will be your place values that are counted as the power of 10. So we know our finite decimal is 2 and 8 tenths. Our leading digit is 2. We multiply by a power of 10, and we count the digits that are given. We see 3, 6, 7, 8 of them. So we have 2 and 8 tenths times 10 to the 8th power. Diamond might throw you off a little bit. Diamond looks like scientific notation. This is scientific notation-ish, but it is not scientific notation. Take a look at the finite decimal. The value is much larger than 10. So we need to adjust that by bringing that finite decimal to be right after the leading digit. And we see that 1 and 124 can also be written as 1 and 24 hundredths times 10 to the 2nd power, which will then be multiplied by 10 to the 6th power, making this 10 to the 8th power by the product of powers. So we have 1 and 24 hundredths times 10 to the 8th power. Ice, we see that the finite decimal is greater than 1, less than 10, or is at least 1 less than 10, multiplying by a power of 10, we're good. Olive oil, we see the finite decimal is less than 1. That means that this value is not in scientific notation. 2 tenths is the same thing as 2 times 10 to the negative 1st power. And so when we take 2 times 10 to the negative 1st power times 10 to the 9th power, we see that we have to borrow a power of 10 from here. The power of 10 will be reduced by 1 in order to make this an appropriate value, because negative 1 plus 8 is, or plus 9 is 8. So we have 2 times 10 to the 8th power. There you go. Take a moment to pause. Make sure you write this down, because this is going to be the big piece you have to know if it's in scientific notation. All right, here's those values right here. Again, just spread out on number lines. We see that those values are between 2 times 10 to the 8th and 3 times 10 to the 8th. And when we expand that part of the number line to a much larger segment, we can see where those values spread out on that number line. And then we could continue to magnify that more and more. Diamond obviously is not within that part of the number line, and that's okay. Okay. This says you get some cards to be able to talk about scientific notation matching. I would love to have played that with you, because I find this activity is really powerful. We just can't do it with the online class. So what I'd like to look at with you is this. Are you ready for more? Just to extend this a little bit, I want to talk about this piece right here of what is this plus this. So 9 times 10 to the negative 1st plus 9 times 10 to the negative 2nd. Express your answer as a decimal and as a fraction. What I would suggest to you is to take this value and turn it into standard notation, into a decimal form. And we can look at it for the decimal value. We can look at that as 9 times 10 to the negative 1st power. We take 9 and we change that into 10 to the negative 1st power. Remember, that's 9 times 1/10, because we're thinking reciprocal. And this one, we're going to add this to 9 times 1/10 squared, or 1/100th. And now the question is, can I just add these two values together? The answer is no. They don't have the same product, or they don't have the same product. So I have to think first in order of operations. I have to think about multiplication here first and multiplication here first. 1/10 of 9 is 9/10. And 1/100th of 9 is 9/100ths. So when we think about the decimal value, I can look at this value and say as a -1, that means bring my decimal back one place value, giving me 9/10, plus to the hundred, or to the negative second power, it's two place values, and you can see that you get 9/100ths. And we know that this would be 99/100ths. As a fraction, I can take this as 9/10 plus 9/100ths. And then I know I need to have a common denominator, so if I multiply this by 10 to get to 100 and this by 10, I get to 90, and I see 99/100ths. And if you can catch on to that, you'll actually catch on to the pattern that's going to happen with number 2, and then you'll be able to answer a couple of these questions. This is where we're going in future lessons, is how to add, subtract, multiply, and divide in scientific notation. What I really need you to get out of this is that you cannot add or subtract in scientific notation unless, until is what I'm going to put, until powers of 10 are equal. And our evidence is right there in the fractions. We'll get into that one in a future lesson. To wrap this all up, what we would be looking at is in our summary, is this the total value of quarters made? We talked about these pieces. What I really want to get from you in this in scientific notation is the values that we have to recognize with these. For scientific notation, the symbol that's used is an X. It's the standard way of showing multiplication. If we are going to use the bullet symbol, we have to write something. If we have 4 8/10 times 10 to the 7th power, if you want to use the bullet symbol, you have to put the 4 8/10 inside of parentheses and show the decimal, or show the bullet symbol for the multiplication. We have to have consecutive powers of 10. We have to have that power of 10 be multiplied by the finite decimal. This does not quite explain exactly where I was going with this earlier, or what the intent of the lesson is, but we have to understand these pieces right here. I should also say when n is greater than 1, then, or greater than 0, I'll just put this n as positive. The values are greater than 1 when n is negative. Values are less than 1. That doesn't say on, that's a bullet point. One misconception that we see is sometimes people think they're going to get to a negative value with a negative power, and that's just simply not the case. So hopefully that kept track and that makes sense to you. Thanks for tuning in. Remember, this is the big part of today's lesson. You're going to expect to be writing numbers in scientific notation and then completing basic operations with them today in your homework. Let me know if I can help. Reach out to me for that help. Hope you have a great day.